Hey there, welcome to a video discussing absolute value function graphs. This is an extension of 2.7. So here, excuse me, we're going to start by graphing a piecewise function. Here we have y equals x if x is greater than or equal to 0, and y equals negative x if x is less than 0. We already practiced this in class last time. And this function is also known as a piecewise. Actually, well, we know that this is a piecewise function. But it's also known as an absolute value. And I'll explain why in a sec. But if we graph it, here's y equals x. But we talked about we only want to keep a portion of that. So I'm going to erase this line. And we're going to keep this portion right here. And the point is included. And the other one is y equals negative x, which is that. I'm only going to keep the portion of x is less than 0, so I'm only going to keep the left side of 0. So again, I'm going to erase that line. Do it again. Now, the 0 is not included, but because it's included in the previous line, we leave it filled in. And there's the graph of that piecewise function. Now, this is also known as an absolute value function. Here's the reason why. Let's say if y equals absolute value of x. You make a table. Plug in 0, I get 0. I do see 0, 0 right there. Plug in 1, I get 1. I do see it right there. Plug in 2, I get 2. I do see it right there. If I plug in negative 1, I get 1, which is right there. Plug in negative 2, I get 2. So what's happening is that this can be expressed as a piecewise function we just graphed. Because of course, y is going to equal x if x is positive. They're going to be the same thing. Or you change, if your input's negative, do a negative of a negative, make it positive, and that's how you get the absolute value. So those are the same thing. So y equals absolute value of x, the graph of that is actually a piecewise function. Now what we're going to do is we're going to actually move this graph in different places. And here's a general form. We actually call this the vertex form, where h and k is the vertex. We're going to discover what what h and k actually, how that will actually move the graph. And there's also an a that we're multiplying to the absolute value. Just so you know, the vertex is a sharp corner. It's going to be the highest lowest point of an absolute value graph. Now, you might be familiar with Desmos. If you go to desmos.com, right here, and go y equals, and then absolute value, you have to pull it up, which is right there. And there you go. Now, what if I do some things to it, like add 1? Notice how the graph goes up 1, minus 1, goes down 1. Or what if I, on the inside, I do a plus 1, it goes left 1. Or minus 1, it goes right 1. Or if I put a 2 there, it gets skinnier. Or 1/2, it actually gets wider. So there's certain things that how this graph will change. And they're called transformations. So A, H, and K transform our graph. And this is going to take some time to really let this sink in. This is the first time you're probably seeing this, but we're going to talk, this is going to be a repeated theme throughout the year for every unit. We're going to be transforming graphs. This right here, we call the parent function, because it's the most basic absolute value I can think of. We're just going to introduce stuff to it. So remember we did this. The graph got narrower, or when I put 1/2 out in front, it got wider. So basically this changes the width of the graph. It actually causes, to be more precise, a vertical stretch. So it's like the graph is getting stretched when it gets narrower, or wider, it's kind of getting squished, if you want to think of it that way. Now, when I did this, and definitely play with Desmos if you like, just go to desmos.com and start graphing. That moved left one, that moved right one. So this caused a horizontal shift. And then lastly, I do that, or I do that, or that moved up one, or down one, so that caused a vertical shift in the graph. So we're going to do some more graphing here. So again, if I go back to Desmos and put a 2 there, we see that we have 0.00 still, but x equals 1, we have 2, and x equals -1, I have positive 2. So see how the graph got vertically stretched. And we tend to say by a factor of 2 because it's like the slope is now 2 instead of 1 compared to what we had over here when we graph the y equals half psi of x, which is the same thing as that piecewise function. So this right here, y equals half psi of x. Now in this case, it's going to move to the left, because if I plug in -3, I get 0. That's my new vertex. If I plug in -2, I get 1, or -4, I also get 1. So this shifted 3 left. So again, the general form, the vertex form, I guess, is that so your h is -3 because you have x plus 3 inside, so h has to be -3 to make that happen. And because h is negative, it's going to go left. So the h, as I mentioned, is responsible for the vertical shift. Sorry, h is responsible for the horizontal shift. The k, when you're putting something on the outside, is a vertical shift. And the a is responsible for a vertical stretch. We'll also discover it's responsible for reflection about x-axis. And we're going to spend a lot of time talking about in class. You're seeing it for the first time here, so it might be a little bit confusing, but when we do more of this in class, it'll sink in. That's going to be a vertical stretch for A. Again, H is the horizontal shift, K is the vertical shift. Okay, we'll do a couple more here. So -1. So I go to Desmos. Oops. Remember, we have +3, so I move 3 to the left. If you have -1, it goes 1 down. And you can even see the dots right here if you want to mouse over. Well, it should say 0, 0, -1, and 1, 0. So definitely use the technology as a guide, or even the graphing calculator. Ultimately, you should be able to do this without a calculator, but for now we use technology to help us. So this is shift of 1 down. And then lastly, it says going to shift 3 left. H is -3. K is -2. We're going to shift 2 down. So that means that I have a point at -3, -2, which makes sense if you plug it in, if you want to make a little table. And if you plug in some points close to -3, like say -2, -4, you'll get those dots right there, both at -1. And boom, there you go. Got your graph. We'll practice this again when we meet again as a class. Okay, we'll enjoy the rest of the weekend. and I'll see you guys later.